So next we're going to talk about code generation for if-then-else expressions. And to do that, we're going to need some control flow instructions. So we'll need two, in fact. So here's the branch equal instruction. And this jumps to a label if the contents of two registers are equal. And then we'll also need an unconditional jump. So this just does an unconditional branch, not a branch, an unconditional jump to a particular assembly instruction. So now let's take a look at the code generation for the expression if E1 is equal to E2, then evaluate E3, otherwise evaluate E4. So first we have to evaluate the predicate, and in order to evaluate the predicate, we first have to evaluate E1. And by now, this pattern for binary operations should be familiar. So we evaluate the first subexpression. We save the result on the stack, so we push it onto the stack. That takes two operations, one to save the result of the accumulator on the stack and the other to move the stack pointer. Then we evaluate E2. Now we've evaluated both of the arguments to the predicate. The result of E2 is in the accumulator, and the result of E1 is at the top of the stack because, again, the evaluation of E2 will preserve the stack. So now we load the value of E1 back into a temporary register, and we pop the stack. And then we can actually do the comparison. So now we do a branch equal. So if the value of E1 is equal, this is actually the value of E2 in A0. If that's equal to the value of E1, then we branch to the true branch. Okay, and otherwise we're going to fall through if they're not equal. Okay, and so we'll call that the false branch. And what are we going to do if we fall through, if this test fails? Well, then we want to evaluate E4, and that will leave the value of E4 in the accumulator, and that will be the value of the entire if-then-else in the case where the predicate is false. So when we're done, we're going to branch now to some code that will just clean up and end the if statement. We'll see what that does in a moment. Otherwise, we still need to implement the true branch, so we'll stick the label for the true branch here. And what do we do on the true branch? Well, we just evaluate E3. Okay? And then the end if, well, actually there is no cleanup to do because E3 and E4 both preserve the stack and they leave the result of their expressions in the accumulator. So we reach end if from E3 if we executed the true branch, and then in which case the value in the accumulator is the value of E3, and we reach end if through this branch if we executed the false branch. And then the value in the accumulator is the value of E4. And so this correctly implements an if-then-else expression.